Hello students, I think that you have completed your classwork copy properly. After completing 3D exercise, I'm going to start your new topic, terminating and non-terminating decimal. In this one, first I'm going to start terminating decimals.
Terminating decimal. A terminating decimal. A terminating decimal is a decimal. Terminating decimal is a decimal with finite number of digits, after the decimal point, after the decimal point. A terminating decimal is a decimal with finite number of digits after decimal point. For example, very important, finite means that it is a limited, you will count easily, okay? For example, 0.25, 3.7587 means that finite. 125.625 means that after decimal points there is a finite number of decimal points, okay? So this is called a terminating decimal. But students, this is the example, but how you will convert a rational number or a fraction into a terminating decimals? So this one is very important. When you are converting a rational number or a fraction into a decimal, if you are converting a rational number or a fraction into a decimal, if its remainder is equal to 0, if its remainder is equal to 0, then the rational number or a fraction is representing a terminating decimal, terminating decimal. Listen, see this one. 5 is going to divide this 4. 4 is not divisible by 5. Take a point, 40. 5 8 40. Means that the remainder, here is the remainder is equal to 0. Means that after a finite step, if your remainder should be 0, then the quotient, whatever the quotient you will get it, that is a form of a terminating decimal. Okay students, so this is very important point. If you are doing a division or if you are converting a rational number or a fraction into a decimal, if its remainder is 0, then the quotient is said to be a terminating decimal. Okay student, now next point is a non-terminating decimal. Okay, here is a second point is second topic is a non-terminating decimals. A non-terminating decimal is a decimal with infinite number of digits after decimal points. Infinite means infinite number of digits after the decimal points. A non-terminating decimal is a decimal with infinite number of digits after the decimal points. So that type of a decimal is known as a non-terminating decimal. I will show you that example. 1.3345 and so on, means that after this numbers means that its remainder will not equal to 0, that numbers will come one by one. A non-terminating decimal is a decimal with infinite number of digits after the decimal points. Okay, there is two types of a non-terminating decimals. Two types of a non-terminating decimal. One more example, you can take this one, 3.3333 and so on. 1.412141, like that, means infinite number of digits after the decimal points. And there are two types of a non-terminating decimal. Non-terminating decimals. There is a two types, first and second. You will write properly. First, there is a two types of a non-terminating decimal. First one is a recurring non-terminated recurring decimal. There are two types of a non-terminating decimal. First one is a non-terminating recurring decimal and non-terminating non-recurring decimals. So first one I have explained here, non-terminating recurring decimal. A non-terminating recurring decimal is a decimal in which a digit or a block of digits repeats in the decimal part without ending. This is very important. Without ending, a digit or a block of digits repeats in a decimal part without ending. A non-terminating recurring decimal. A non-terminating recurring decimal is a decimal in which a digit or a block of digits repeats in a decimal part without ending. For example, 125.777 and so on, means that here not ending, means 7 comes after that. Okay, 777 and so on, without ending. Here is a digit, only 7 is repeating, 120.7. After points only 7 is repeating. Okay, so digit are a block means more than 1. Okay, so for example 1.040404 and so on. Here is a two numbers, two digits are repeating, so this is known as a block of digits. Here is a digit only. So students, very important points. The number, a digit or a group of digits is known as a period. It is known as a period. Digit or a group of digits or a block of digits is known as a period, and the number of digits is known as a periodicity. Okay, here's what is the period of this one. There is a one number is repeating, means its period is 1. Here is 2 numbers are repeating, its period is 2. Okay, so this thing, this periodicity is 2. Period is number of digits. Okay, so periodicity is a number of digits. One number is repeating, its periodicity is 1. Here is 2 numbers are repeating, its periodicity is 2. Okay, means in this one it is not ending. 7 comes, here is a 04 comes, but it repeats after few terms or few digits. Okay, here it repeats after 7 and here it repeats after 04. Okay, so you can represent this one as a dot or a bar. You can write it a bar like that. 125, 1 digits are repeating, put a 1 bar, 1 dot, or you will write this one 125.7 bar, means that 7 7 7 7 and so on. If you want to write in short form, you will write like that. And suppose this one is a 1.04, you write 2 dots, or you will write 1.04 1 bar on 2 digits, means that if you expand this one, you will write 1.040404 and so on. This one you will write it in expanded from 125.777 and so on. Okay, so this is known as a non-terminating recurring decimal. A non-terminating recurring decimal is a decimal in which a digit or a block of digits repeats in a decimal point without ending. Without ending, it is not going to be end. It repeats after a digit or block of digits. Second point is that non-requiring decimals. Okay, now the second point of a non-terminated decimal. Non-terminating, non-requiring decimal. A non-terminating, non-requiring decimal is a decimal in which the digits after the decimal point neither repeat. Very important point is this one, neither repeat nor terminate. Means that its division is not going to be int, as well as it is not repeated. In the first one, it is repeated after 1 digit or 2 digit or more than 2 digits. So that is known as a non-terminating but requiring decimal. But this one is a non-terminating, non-requiring decimal. It means that it is not going to be repeat nor terminate. Okay, so for example, 1.14235 and so on. Not repeating, it is not repeating nor terminated, means it is endlessly moving to the right side of a decimal point. Okay, one more example, you will take this one, you will take this example 2.230675 and so on. Means non-terminating, non-terminating, non-requiring, means that it is not requiring after 1 points, 2 points or 3 points, means that it is endlessly moving to the right side of a decimal points. Okay, so non-terminating, non-requiring decimal. So students, if you are converting a rational number or a fraction into a decimals, so these 2 points is very important. First one is a terminating decimal and second one is a non-terminating decimal. In non-terminating decimal, there is a 2 parts. First one is a recurring decimal and second one is a non-terminating, non-requiring decimals. In recurring decimal, it repeats after digit, after 1 digit or a block of digits after decimal points. But in this non-requiring, non-terminating, non-requiring decimal, it is not neither repeat nor terminate. For example, is this one. So after that, I want to explain you that how to solve your problem. Okay, this point you always remember that, student, how you will know that without actual division, how you will tell that this one is a terminating, decimal, and this one is a non-terminating decimal. It is very easy way you can define that. Suppose rational number is given like 9 upon 25 without dividing. 9 upon, here is the, see this denominator, if its denominator is a factor of, it is a prime factor of 2 and 5. 2 and 5 means if it is a factor of 2 and 5, maybe 2 or maybe 5, then the given fraction is known as a terminating decimal. See this one. We will check this one, it is a terminating or not. 25 is going to divide this 9. 9 is not divisible by 25. See this one, 0 points I have taken, so 90, 3 times 75, 5 is there, 8 minus 7, 1 points is there, so 0, 6 times 150, so it is cancel out, 0.36. After decimal points it is a finite number of decimal and its remainder is equal to 0, means that it is a terminating decimal. If the denominator of a fraction has only prime factor of 2 and 5, then it represent a terminating decimal. Suppose it is a 151 upon 100. So 100 is a prime factor of 2 and 5. Then it is a terminating decimal. But suppose if you have taken 5 upon 34, 5 upon 34, it is a terminating or non-terminating, because 34 is not a factor of 2 only. In this one, if you are factorize this 34, first 2, then 17, then 17. 17 is also there. So if students, if the denominator of a fraction has any prime factor other than 2 or 5, means 3, 4, 6, 7, 8, other than 2 or 5, then the given fraction is a non-terminating decimal. Non-terminating decimal. See this one. Suppose I am going to divide this one, and in non-terminating there is a two parts, requiring and non-requiring. So 50 1 times 34, 6, 1, 60. Because decimal is there, 1 0 you can increase in every step. So 4 times 4 4s are 16, 1 carry, 4 3s are 12, 1, 4 3s are 12, 1, 12, 1, 13, 4, 5 minus 3, 2, cancel out to 0, 7 times 7 4s are 28, 2, 7 3s are 21, 23, 2, cancel out, 0, again 0, 200, it goes with 5 times, means that you can see that its division is not going to be end. It's without ending this division, numbers in the quotient numbers will come one by one, means that it is a non-terminating, non-requiring means it is not repeating. Numbers are not repeating in this one. Digits are not repeating. So non-terminating, non-requiring decimals. So, but the basic points is that this one, if its denominator is a prime factor of other than 2 or 5, then the given fraction is in a form of a non-terminating decimal. And if its factor is a 2 or 5, both 2 and 5 both 2 individual and 5 individual, it is if it is the factor of the denominator, then the given fraction is in terminating decimal. Okay students, and by long division method you can check that if its remainder is equal to 0, then it is a terminating, and if its remainder is not equal to 0, then it is a non-terminating decimals. And if it is repeating, suppose 1.777, if it is repeating, you can write in short form 1.7 dot, because one digit are repeating, you will write 1 point on that repeating terms, you can write a bar on that one. And if it is repeating 2 digits or 3 digits, you can write it, if 2 digits 2 bars, if 3 digits 3 bars, are a single bars on that one. Okay students, so by this way we can change a fraction into a decimal, not a terminated decimal and non-terminating decimal. Okay students, so your exercise is this one, and here is examples are also given, so these examples you can try in your home. Question number, exercise 3E, identify which of the following divisions from a terminating decimal and which form a non-terminating decimals. Question number, first identify which. 3E, first question. In this one, asking that divide this one, and then after you will tell that it is a terminating decimal or non-terminating decimal, which forms terminating decimal and which forms non-terminating decimal. But what I told you, that one rules, if its denominator is a prime factor of 2 or 5, or both 2 and 5, then it is a terminating decimal. By seeing you can tell that it is a terminating decimal. But by using a long division method, by using long division method, by using long division method we get. So here students, I'm going to divide this one by 8. I'm going to divide this 5 points 50 6 times 48, 2 cancel out, then decimal 0, 8 2s are 16, 4, then you can increase 1 0, 8 5s are 40. This cancel out, means that remainder is equal to 0, means it is a terminating decimal. So 5 upon 8 is equal to 0.625. It is a finite number of decimal points. Finite number of, there is a 3 decimal points, so finite number of decimal points. So it is a, hence 5 upon 8 is a terminating decimal. It is a terminating decimal. Now that question number 4, question number second one is question number second. 13 upon 15. By using rules, if it's a denominator, you can see this prime factor of 15 is by 3, 5. Other than 2 or 5, if the prime factor of a given denominator other than 2 or 5, then it is a non-terminating decimal. So by using a concept, it is a non-terminating, or by using this division method, we will check that it is correct or not. By using long division method, long division method, we get. Okay, so here I'm going to divide this 13 by 15. So see this one, student, 0.130. So 8 times 15, 8 are 120, 0, 10, decimal, 6 times 90, 0, 1, 6 times 90, 0, again 6 times, means that you can see that after and so on, means that after 8 then 6, it repeat 6. It is a non-terminating but requiring decimal numbers, 0.866 and so on, or you will write this 0.86 dot, or you will write that bar, means that it is a non-terminating decimal, and in non-terminating it is a non-terminating requiring decimal. Hence 13 upon 15 is a non-terminating decimal. Non-terminating decimal. Okay, so by this way you can do that question number third and fourth. Then after I am going to do this question number first, fifth. Here is this one, question number second, and then after third and fourth you will do with yourself, students. This one you can see this remainder not is equal to 0, means that it is not ended. Its division is not ended. So it is a, by seeing you can tell that it is a non-terminating decimal. Now that question number fifth. By using a long division method, I am going to divide this 1.23 by 4. See this one, 1 is not divisible by 4, then we take this 2 digit, so take this decimal in your quotient. So 4 3s are 12, cancel out, 3 comes downside, 3 is not divisible by 4, because you have taken a decimal, so you can increase 0. Here also you can increase because you have taken a 2 terms in a one time. Okay, so here you see this 3, then after if you want to because 3 is not divisible by 4, take 1 0 here. Here is 30, because 2 terms in a one times, if you are taken a 2 terms in downside, you can increase 1 0 in your quotient. Okay, so 7 times 7 4s are 28, so 2 there, 2 is not divisible by 4 because you have taken a decimal, so you increase 0 in one times. So what you will get it, 1.23 upon 4. If you are changing into again decimal, so you are getting 0.3075. So it is also a finite decimal points. So hence 1.23 upon 4 is a terminating decimal. Terminating decimal. Same as it is, you will do that question number 6 and 8. Now 6, 7 and 8. Okay students, in next video I will solve that question number second and third. Okay, so for today's this is a first question only. Okay,